remember at position A is where we have the minimum velocity, so that we say that tension here is given by tension is equals to mv squared over r minus mg. Remember, this is the centripetal force. So that we say that because at this position, so we have the minimum tension, so we say that T is given by mv squared over r minus mg. Taking T to be as minimum as 0, you get that 0 is equals to mv squared over r minus mg. And therefore, moving mg on this other side, you get that mg will be given by mv squared over r. Multiplying both sides by reciprocal of m over r gives you that v squared is equals to rg, and finding square root on both sides gives you the square root of rg. That implying that the radius being the r being the radius of the uniform circular motion and g being the pull of gravity, so the velocity minimum or the velocity at this position A will be given by the square root of rg. Then for position B is where you have the maximum tension. Remember, that is also the position where we have the maximum velocity, the velocity beyond which, when exceeded, the rope or the string is likely to snap or break. So therefore, we say that potential energy at this position B is the same as the total energy at this position B is the same as total energy at this position A, because from the law of conservation of energy, energy is neither created nor destroyed, but transformed into other forms. So we say that the potential energy at position B here plus the kinetic energy at this position B here is the same as the potential energy at this position A plus kinetic energy at this position A. Remember, at this position B here, we don't have any height in terms of the distance and the position of the object. Therefore, we say that the h is 0, meaning the potential energy is 0. It becomes 0 plus a half mv squared, you don't know the velocity, is equals to mgh at position A. So remember, when it is at this position h, the distance from this point to this point is the same as the diameter of the uniform circular motion or of the circular motion. So we say that from A up to B can be given as diameter, which can be written as 2r. So then plus a half mv squared. Remember, from this first part, we said that the velocity minimum or the velocity at this position A is given as root of rg. So it becomes a half m in bracket the root of rg squared. Then dividing through by m, because m is common here, here, and here, it leaves you the half v squared b is equals to 2rg or 2gr plus a half gr. So that when multiplying through by the reciprocal of a half or making vb the subject, you get that vb is equals to 4gr plus gr. Then adding this to this or collecting like terms gives you vbr is equals to the square root of 5gr. So that still the gravity or the pull of gravity is g, and r is the radius of the circular motion to get the maximum velocity beyond which, when exceeded, the rope will snap. So remember, when it's snapping or when it's breaking, it normally follows a path that shall be shown in our next subtopic. And as well, if you have any topic concerning the uniform circular motion or any topic of your interest, kindly send your question on the email at our profile or our bio. Have a nice time. Kindly subscribe.